All right, everybody. My name is Chris Jacobs. I'm a product development engineer for Replacement Parts Industries, and I'll be doing a presentation today on the Tuttnauer E-Series sterilizers. So I apologize, this is not going to be over any of the Easy 11 Plus or Easy 9 Plus units. This is just strictly for the Tuttnauer E-Series, like your 2340Es, EKs, EKAs, those kind of units. So with that said, let's get started. First, we're going to get familiar with some of the key components on the Tuttnauer sterilizers, starting with the display board, which is right behind your LCD display and keypad area. The important part about this board is that there is a keypad in the front, and the LCD display is sandwiched between that keypad and this display board. Now, in the top right-hand corner, you'll see a large pot labeled Pot 1. Anytime you do a new LCD install, you're going to need to adjust this. This adjusts the contrast for your LCD display. Next important item on this board is, of course, your microprocessor, which acts as the brain, contains all the software for this unit. Next is the clock chip, which that item basically handles all your small-term memory items such as your date, time, specific cycle settings. So those go out about every 8 to 10 years. Signs that those are failing is going to be that you have dates being misprinted on your printouts, any cycle information, custom cycle information that's being lost repetitively. That's a good sign that that chip is actually failing. Next, we have the water pump solid state relay. This is, of course, just acts as an electronic trigger to allow your pump to run. Next down is, of course, the air compressor solid state relay. Again, just an electronic trigger to allow the air compressor to turn on. Your power switch, which of course allows power to go into the unit. Your power supply board, which at the top left of the board, that is your incoming 120 volts AC. At the bottom of the board, you'll see a black, orange, and red wire that is going to be your ground, your 12 volt line, and your 5 volt line DC that goes out to your adjunct board. Then of course we get to the adjunct board, which this is responsible as sort of an input-output board for these units. This is what you'll be calibrating anytime that you go in to do a calibration. The solid state relay for the heater. This is again electronic trigger to allow your heaters to turn on. It is the only one that has the white plastic casing over the front of it. So that's how you identify it from the other two. And then of course your cooling fan or axial fan. This is just to cool off the electronics. Right behind the electronics housing, you'll see your pressure transducer, and of course this is responsible for recording any pressure that the unit has. Next, we're going to go to the water pump. Of course, this is responsible for getting water into the unit and is controlled by both your adjunct board and your solid state relay that we just discussed. The air compressor. Of course, this is responsible for drying the chamber and again controlled by one of the solid state relays and your adjunct board that is at inside the electronics housing. Safety thermostats. There's two. This top one that we've highlighted here, this is the manual. It says a little red button on the back. It'll pop out if the unit gets too hot. Now, one of the things that's usually a good indicator that not only this one is being activated is also the one right below it is the automatic reset. Now this one's set to go at a lower temperature. So if you're triggering the manual, probably your automatic is not functioning at the same time. Next is your air outlet valve. This is right on the back of your actual reservoir tank. This particular solenoid is the one that acts sort of as almost as a bellows on newer style units. It's going to close at 194 degrees Fahrenheit and allow you to build pressure. Up until that point, it's just relieving cold air. Way in the back there is the air valve, which basically just opens up and allows the air compressor to put air inside the chamber for closed door drying. Your fill solenoid, of course, coming from your water pump allows you to open up a path to put water inside the chamber. Then finally, your exhaust valve, or as some people call the vent valve, this is responsible for venting the chamber at the end of a cycle. Your circuit breaker in the back has the big red toggle on it. That is, of course, just like any other circuit breaker and how they function. Right in the back is your water fill electrode. These do not work as you might have seen on min-marks and things like that. They do not. They are not constantly monitored. So how Tuttnauer does it is they fill the chamber for a timed amount, and then after that timed amount is completed, it will check to see if there's enough water. If this tells it that there is not, it will continue to run another timed cycle. So this will not cut out as soon as your unit is full of water. Temp sensor, of course, this is just monitoring temperature inside the chamber. And this is also the item that you'll be unplugging when you go to do the calibration. Okay, inside your reservoir, the small piece that has a little wire on it, that is called an air jet valve. That is part of your PM kit and needs to be replaced annually. It is responsible for removing small portions of cold air from the chamber. Your air valve will be responsible for the bulk of it, but once that closes, this is what takes over and controls relief of pressure. Right next to it, sticking out the end with a key ring on it, that of course is your safety valve. There's two different types. There's a 37 PSI and a 40. They both look the same, act the same, just acts as a pressure relief in case the chamber gets too high in pressure. And then of course, in the bottom there is your condensation coil, which just essentially cools the water, cools the steam as it comes back to the reservoir. Now, when you go to set up a unit for the first time, one of the things you're going to want to do is level out the unit and make sure that the water input is correct. So on the top right picture, you'll see the leveling feet. Those are on every Tuttnauer unit. They're the only ones, the back ones do not level. And then the bottom right-hand picture, that's the fill groove or indication groove for your fill line. Every unit has a specific number of ounces that need to go inside the chamber, which I'll show you on the next slide. What you're going to want to do is grab that set amount of water, pour it into the chamber, and you want to use the leveling feet to get it within plus or minus a ½ inch of that fill groove. So on the top right there, you can see each unit and how many ounces of water, or if you deal in milliliters, for each particular size of machine. For units that do not have a water pump, what you'll do to set the filling time is once you have leveled the unit with the proper amount of water in it, what you're going to do is you're going to power down the unit. You're going to push the water inlet key, which is on the bottom right there with 2 arrows on your keypad. You're going to push and hold that in while you power up the power switch. You're going to let go for just 1 second and then push it again. And you're going to keep holding it until the water inside the chamber reaches the fill groove. Once it does, let go of that water inlet key and then push stop on the unit and then power it down. That should be set for the future for the units that do not have water pumps. Now, for units that have water pumps, what you'll do is you'll hit the stop key what you'll see on the display is a code 102. You want to use your up keys or the up key to go up to code 105. That code will then, you hit stop once you get to code 105, and that will ask you for fill time. You can adjust it using the up and down keys to the size of unit, which located in the bottom right will be the time that you need to set for each size of unit. Once you've got it to the time limit that you need, then you'll be hitting the stop key again. And that should set your water fill for machines with water pumps. Now on these units, there's your 4 standard setups, unwrapped, wrapped, liquids, glassware, and of course an extra drying cycle with the emblems to match for each. Now, going back one slide, at the right below your display, there's the temp, STE time, and dry time keys. These keys are used to adjust any cycle parameters that you want to. Of course, pressure is not one of them because pressure is just a correlation of temperature. Next, when you're setting up a unit, on the backside of your display board, there are 8 dip switches. Each is responsible for a different setup within the machine. The first 2 switches is just numbering. All that does is if you happen to have multiple Tuttnauers in your facility and you want to know which printout is for which machine, you can turn these dip switches to label them 1, 2, 3, and 4. Switch number 3, that's going to lock the keypad. Now, sometimes if you go into a facility and they say the keypad is not working, I highly recommend that you check this switch first. This is usually responsible for keypads not functioning. So make sure that you give it, turn it off, turn it on, and then turn it back off again. Switch number 4, that is enable the preheat function, which you can do on all units, but it is mandatory that you do it on the 3850 or 3870 series. Switches 5 and 6, this is just simply to change between metric and standard temperature and pressure ratings. So to change from Fahrenheit and PSI to Celsius and kPa. Switch number 7, that was just a factory setting for Tuttnauer to use, so just leave that in the off position. And then switch number 8 is to enable or disable your printer. So if you are using a printer, make sure that that is turned on. All right, next up, we're going to discuss calibration. I realize that some of our virtual viewers are not able to see what I'm doing here. So if you need to take a better look, there is a full calibration video on our website that you can check out. It goes through every detail of calibration. For those sitting in the room, I will go through a few short things. Of course, inside the calibration kit, which we have listed here, this is our part number TUK108. In the right-hand side, you're going to have various different connectors that will allow you to connect to the Adjunct 3 board, the Adjunct 2 board, or the ANL T2 boards. Left of that on the bottom is going to be your test point board. Next over is your pressure gauge. And the last one on the end is the test box, which is going to simulate temperatures for your temp sensor. Up from that is going to be the ribbon cable that's going to connect your test point board to your adjunct board. And then of course there's a few, there's a trim pot adjustment tool, a max register thermometer for checking the interior temperature, and then a booklet which is going to give you calibration information, how to do it, and also test points, which I will show you in just a moment. To get started, all you're going to do is you're going to take the ribbon cable and connect it to your test point board, which is then going to get connected to the right-hand side of your adjunct board. And then you're going to take whichever connector on the right-hand side is going to be for your particular board. You're going to connect it to the test box. And then that is going to get connected in the place of your temp sensor on the back side of the electronics cabinet at JP11. Once you have it all set up, you're going to take your pressure gauge, you're going to install it on the back of the unit where the temp sensor T is located. Once that's installed, then you're going to power up the unit. You're going to want to just have the door open, leave it sitting there as normal. You're going to want to take your meter and connect to test point 25 with your black lead and test point 26 with your red lead. And what you're going to be looking for is you need negative 5.1 millivolts. It's important that you know that your meter is reading millivolts and not volts. This is also a very tricky calibration setup because that negative 5.1 is a trigger for one of the chips that's on the board. So getting to negative 5.1 and having it hold there may be a little complicated. So if you end up at 5 or 5.2, that's fine. After that, you're going to disconnect from test point 25 and 26, and you're going to go to test point 1 and test point 7. Then you're going to turn your test box all the way up to 273 degrees. And what you're aiming for is 2.385 volts. And that is volts, not millivolts, on your meter. And then you'll be adjusting pot 5. After you've adjusted to 2.385, you're going to make one last adjustment. But before you do that, what you're going to do is you're going to shut the unit down. You're going to push in on the door switch. And then you're going to power the unit up. You're going to keep holding that door switch for 5 seconds. What should happen is on your machine, you should see the pressure zero out. If that does not happen, you may have an issue with your adjunct board. So next, take your black lead, keep it on number 1 on the test point board, and then you're going to take your red lead and put it on test point 4 on the test point board. Next, you're going to go to pot 2, and the adjustment is 500 millivolts. Now, again, this is a very sensitive setup. It's the only one, or this one and the negative 5.1 from the beginning are the two sensitive ones. It can be pretty difficult to get them to calibrate to that exact setting. Once you've calibrated it, that pretty much completes your calibration. What you're going to want to do from there is shut the unit down. You're going to disconnect just the test box. You're not going to disconnect your test point board. Once you've disconnected it, plug back in your actual temp sensor, power the unit up, leave your meter at pins 1 and 4. It should still be set to 500 millivolts. And you're going to run a cycle. Doesn't matter which one, you can choose unwrap, it's the fastest. And as your pressure climbs inside the machine, you should see that 500 millivolts go from 500 millivolts to around 1.5, usually a little over. It's usually like 1.51, 1.53 volts DC. And once everything checks out, you run a full cycle, get up to 273 and 30 PSI, you're good. That is the finish, that finishes the calibration. If you'd like to check anything else inside the machine while you're there, inside that booklet, the TUK 108, at the back of it, there is this. And this is also for the Adjunct 2 and the ANLT2 board. This will give you every test point to check every electrical signal inside the machine. This is also located on our website as well if you want to go ahead and download it. After you're finished with calibration, you may wish to do a preventative maintenance, which inside the maintenance kit, there is going to be the door gasket, located obviously right inside your door, the door bellows, which is located at the end of the door behind the door housing, door bellows housing bolt, Then there's going to be mesh chamber filters, which should be inside the chamber and the 2 ports that are actually open. On an EA unit, such as an EZ9, EZ10, or any of the other EAs, you're going to have a HEPA filter, which should be linked to a cap that is on the side of your top cover. That no need to be replaced annually. The air jet valve, which we showed earlier, and usually if you want to at the same time run any kind of cleaners, there's Tut Clean for us. I know Tuttnauer uses Chamber Bright. Those are the last items that would be included. Now, Tuttnauer has done some PM kits which have also your safety relief valve and all of your valve repair kits. We showed all the valves earlier and the safety relief valve, which up to you on if you're going to do that type of repair for an annual maintenance. Now, lastly, just have some information here on RPI, on our website. We have free tech support over the phone for these units, myself and about 4 other engineers. There's also, as I mentioned at the beginning of the briefing, that there is a full calibration video on our website at the Tech Help Center. And there's also some exploded views on our website, especially if you're dealing with not just the E's, but the M units as well. We do have some nice guides that will give you some more information on them and the problems that you might see with them. So that is it for right now. If anybody has any questions, they can let me know.